Welcome to qnawire.
Okay, so we're going to solve the following problem. An airplane takes off from an airport and lands an hour later at another airport 400 miles away. If t represents the time in minutes since the plane has left the terminal building, let x of t be the horizontal distance traveled and y of t be the altitude of the plane. So our first task is to sketch the possible graph of x of t. So recall x of t is the horizontal distance traveled. Okay, so to do this, we're going to start by, let's see, we're going to draw our x and y coordinates. Well, actually, in this case, it would be our t for time coordinate, and our x would be as a function of t. Okay, so x of t, again, is going to be our horizontal distance. Well, our total distance we're going to travel is 400 miles. And we're told that we're going to be covering 400 miles in 1 hour. So at the end of 60 minutes, our trip will be over. So an example of what this graph might look like would be if we started at 0 from the origin. So 0 miles covered, 0 minutes traveled. We're going to take off, and then our velocity will increase and then eventually stabilize as the plane starts cruising. And then eventually it will start decreasing again until we land. And at this point, we will have reached our 400 miles in 60 minutes. Okay. Task B is to sketch the possible graph of y of t. Recall that y of t is the altitude of the plane. Okay, so our plane is, again, so now this is t, and this is y. Here we go, this is y. Okay, so again, this is going to take a total of 60 minutes. And we're going to start off from the ground, and eventually we're going to reach a cruising altitude, at which point the altitude will not increase. And eventually we're going to start preparing for departure, and we're going to land after 60 minutes. So that is an example of a graph for what y of t should look like. Okay, now we're going to sketch a possible graph of the ground speed. So this is the speed of the plane with respect to the ground. And this is going to be similar to horizontal velocity. So we're going to have a graph as a function of t. And now this is our ground speed. So we don't have a variable for this as yet, but it's going to look something like this. We're going to increase, stabilize as we reach a cruising altitude, and then decrease. Finally, our last task is to sketch a possible graph of the vertical velocity. Okay, so now we are looking at a graph, and here we're going to have x of t. So recall again that x of t is the horizontal distance traveled, and y of t, the altitude of the plane. And now as our velocity increases, plane's moving forward, and then we're going to reach our cruising altitude, and then we're going to decrease for landing. Here in the middle is going to be our cruising altitude. Okay, so these are 4 graphs that represents different situations that we've been presented with.